So now we will move towards the next type of governor, which is the Wilson-Hartnell governor. Now we will move towards the Wilson-Hartnell governor. In this type of governor, we use the tension springs at the place of compression springs as we used in previous spring-loaded governors, that is in Hartnell governor as well as in Hartung governor. Okay, you can see here that there is a mainspring, that is the tension spring through which both the balls are connected. As the speed changes, its speed increases, the balls will move in outward direction and this spring comes under tension due to this outward centrifugal force and try to resist the outward motion of this ball. The load on the sleeve is maintained by the self weight of the sleeve as well as an auxiliary spring arrangement. You can see here this auxiliary spring is connected at end of the lever. If the sleeve moves in upward direction, thus there is a tension in the spring, in this auxiliary spring, and if sleeves downward moves, then this spring is compressed. So now let's consider the force diagram or free body diagram of the system using this line diagram shown in the second figure. Fc is the force exerted by the centrifugal movement of balls. P is the tension in mainspring or ball spring. S is the force generated in the auxiliary spring. The radius of rotation of the ball, the mean radius of rotation of the balls are small r. Pivot distance is same from the axis of rotation. Initially, we can assume that the balls are vertical. Ball lever arm is vertical, and capital M is the mass of sleeve, small m is the mass of ball as usual. SB is the ball spring stiffness, that means the stiffness of this spring, and SA is the auxiliary spring stiffness, that is spring auxiliary spring stiffness, SA. Fc is the centrifugal force acting on the balls. R is the radius of rotations of the balls. Now if we consider the movement of forces about this point O and half portion of the lever, say this portion, then we can write this equation easily. Fc into x is one anti-clockwise movement, P is clockwise movement, so net anti-clockwise movement is Fc minus P, and the movement due to the weight on the sleeve is the weight on the sleeve, one portion. The total weight is basically mg plus s into b by a, but both the levers handle half of this weight. That means the load is equally distributed on both the levers. Therefore, we divided it by value 2, and its movement, taking the movement, we multiplied this distance y. So this equation can be written by considering the summation of movement about point O equals to 0. Now we will see the force balance at the minimum speed and force balance at the maximum speed. There is not much change in the above equation, but at the place of Fc, we replace it by Fc1, that is the centrifugal force acting on the balls when the balls are rotating at minimum speed, and P1 is the spring ball force when the balls are moving with minimum equilibrium speed. And this S1 is the auxiliary spring force when the balls are moving with the minimum equilibrium speed. Similarly, for maximum equilibrium speed, we can write here FC2, P2 and S2. All other dimensions are same in both the cases. Now, if I subtract the equation 1 from this equation 2, then I get this relation between the stiffness of the spring at the ball and auxiliary springs and the net extension force from minimum speed value to maximum speed value in ball spring and the extension force in the auxiliary spring when the balls are moving from the minimum speed to maximum speed level. If the auxiliary spring is not given in the problem, then we consider SA equals to 0. That means there is no auxiliary springs available in the system. So this whole arrangement is neglected and the force induced by this auxiliary equation becomes 0 by considering its stiffness as 0. So using this particular relations, we can easily solve any problem of Wilson-Hartnell governor. Definitely, in the solution of problem, we will use the geometrical consideration of the system given. If you have any doubt or query related to these topics, you can send your doubts or queries on the numbers given below. Thank you.